So in this problem, there is a function f of x, which is defined as 6e to the negative x over 3. And it wants the first four terms and the general term for the Taylor series about x equals 0. So since this is working with e to the x, a form of e to the x, and it is going to be a Maclaurin because it's centered at 0, instead of finding all the derivatives, what you want to do is work off of the known function e to the x. So I know that e to the x looks something like this. So e to the negative x over 3 just means you replace the x with negative x over 3, and then the 6 in front just means you multiply everything through by 6. So the first term just becomes 6. The next term we're going to have a 6, and then we're going to replace that x with negative x over 3. So I need a 6, negative x over 3 squared over 2 factorial. I need 4 terms, so I need one more here. 6, negative x over 3 cubed over 3 factorial. It is a series, so put a plus dot, dot, dot. And then it also wants the general term. So what I would do is figure out the general term for e to the x, which is x to the n over n factorial, and then replace that x again. And there's your general term for this one. So again, no simplifying, just leave it like that. Okay, now in part B, it says there's another function called g, which is the antiderivative of f of t. So they want you to find the first 4 terms of this new function g. So we're going to go ahead and integrate the function that we came up above. Now this is where now I want to maybe simplify things a little bit because that'll make it easier when we have to integrate. So what I'm going to do before I do the integration for part B is I'm going to clean this up a little bit. So notice the second term, the 6 divided by 3 gives me 2, and I have a minus sign. All of this, if you clean this up, 6 divided by 2 is 3 on the top, and then you have this 3 squared on the bottom, so really all you end up with is a positive x squared and the 3 on the bottom. So you can do the arithmetic to check for yourself. The next term here, notice it's going to be a minus sign. I do have an x cubed. You have a 6 on the top, 3 factorial is also the same as 6, so 3 cubed on the bottom is 27, etc. Okay. I'm going to clean this up a little bit too. The only thing I can do is just, let's break up that fraction. So I'll put the 3 to the n on the bottom like that. Okay, so this says g is the integral of f of t. So we're going to replace x with t in the function, and it wants the first 4 terms. So there's my first 4 terms. And when I integrate it, I end up with 6t minus 2t squared over 2 plus t cubed over 3, so that becomes 9. T to the 4th over 3 times 27, which is 81. And then notice here, if I plug in the x, everything just changes to x's here. I'm going to clean this up a little bit. And then if I plug in the 0, everything zeroes out. Notice it does also ask me to find the general term, but again, you don't have to try to figure out a pattern here. This was our general term from above. I can go ahead and take the antiderivative of the general term. The 6 stays because it's just a number. Add 1 to the power, divide by the power, and then everything else just stays. So there's my general term there. Okay. Lastly, part C says there's another function called h of x, and h of x is f prime of ax times some constant k. And a and k are both constants. The Taylor series for h is given by this function. Okay, we need to somehow find a and k. Okay, so first thing, there's a couple ways to do this, but first thing you should notice is they actually give us the series for h, and if you look at the expanded notation, notice that h of x is really e to the x, right? This is just the series for e to the x. So they're telling us that h of x is really kf prime of a of x. Well, I know this is e to the x. We just saw that from above. I need to figure out what this is. But I can do that because in the very original problem, they told us f of x is 6e to the negative x over 3. I can find f prime of x, right? That's just the derivative. That would, remember, the derivative of e to the u is e to the u, so the 6 is still there. But then don't forget we have chain rule on that u, so the derivative of negative x over 3 is negative 1/3. So this really simplifies to this. But what do I need? I need f prime of ax. Well, what does this mean? This just means replace x with ax in the function f prime. So that would be negative 2e to the negative ax over 3. And then putting a k in front just means multiply by k. So this is all of this piece right here. So now I have two functions equal to each other, and I can figure out what k and a are. Okay, first of all, let's start with the k. The number in front of e to the x here is 1, so 1 has to be equal to negative 2k. So the only way that can happen is k is negative 1/2. And then here, the exponents have to match up because I need them to be equal. So the coefficient in front of the x there is also 1. The coefficient in front of this one is negative a over 3. So that means really a is negative 3.